everyone, welcome back to the Staad Pro class. In the previous class, we had covered up the basics of how to verify our results, right? In this class, what we'll be doing is we'll be working with a beam like this, and I'll be explaining to you how we can add loads in this direction, like how they have done here. They have not applied the load completely on this beam. They have applied partly. Same thing goes for this UV area, this uniformly varying load. How they have applied this load at this distance. Okay, so that is what we'll be looking at majorly in this particular class, where we'll be doing a continuous beam and we'll be checking it how to get results and everything. Okay, so without any further detail, let's get started. So I'll come back here. I click on my new project very quickly. I'll just change it to some random name. Take space, next, add beams, finish, and we get the screen for us. And the very first thing that we do is we just close the grids part, right? We don't use the grids part. Okay. So once that is done, the first next thing that I have to do is I have to get the node points. So if you see here, the distance is 5 meters, 3 meters, and 4 meters. So if I were to draw this in this one, let me just show how it will look. Okay, so it looks something like this, and I will have. If I just open up and see this, 1, 2, 3, 4 of them we have. And one last here. Okay, then I use a paint. Just make this. All of them are simple supports. There is no fixed support here. Okay, we just see this diagram, we'll get to know that there are no fixed supports, all are simple supports like this. Okay, and then this is just 5, 3, and 4. So how will this look? Basically how it will look is, if I have to draw the node points for this, my node point here will be 0 comma 0 comma 0. Okay, this is going to be my very first node point. Okay, after that my second node point is going to come at 5 comma 0 comma 0, 5 comma 0 comma 0, because it is not going to move either in y or x direct, y or z direction. Okay, let me just pull this back. Yeah, we like we spoke about last time, x, y, and z. So 0 comma 0 comma 0 will be the very first node. All right, and the second one is that coming at 5 meter distance, and then it is coming at a 3 more distance, so it will be 8. Okay, because all the values we take it from this point. So if someone has doubt so far, let me just do this for you. So this is going to be one more axis, and this is going to be one other axis. Basically, this is going to be my y-axis. Okay, and let's make this as z-axis. All right, and this is going to be my x-axis. Just stay it in black and just drop it here. X-axis. Okay, this is how it's going to be. So we're just moving in which direction? We're moving only in the x direction. The nodes are moving only in one direction. Okay, they're not moving up or they're not moving front. Okay, they're just moving in one direction like this. Okay, so from this node to this node, I have to find the distance because everything is taken in the coordinate system. This is going to be 8 comma 0 comma 0. So if I just do this 8 comma 0 comma 0. Why is it 8? Because the distance from here to here is 5, and then from here to here is 3. So 5 plus 3 is going to be what? 8. And then last but not the least, we have got 4 meters again here. So I have to drop one more here. Let me just very quickly draw this. It's going to be 8 plus 4, 12 comma 0 comma 0. Okay, so if I were to just write the distance here, the distance is going to be 5 meters first. Okay, then the distance is going to be how much? 3 meters, and then the distance is going to be 4 meters. I can just make it on the top. That's much better. Like this. All right. This is the same thing that we have done. So I hope you have understood the coordinate points, how we are taking it. Okay, so don't worry about the loads and everything. Like so the load is starting from 1 meter. Why are not giving any node there? Because there is no node over there. A, B, and C, D are the only nodes that are there. Okay, whatever the loads are there, we have to apply them by giving them the distance. I'll show you how we can do that. Okay, so let's start doing this 0, 5, 8, and 12. So I'll just come here. I'll give 0. I'll give enter. The first point has come. Then I have to give 5 meters distance. So I'll give 5 again. This is in meters, M is in meters. Okay, don't get confused. And then I have to give 8, enter. And then I have to give 12, enter. Okay, right now everything is going in x direction like this, like the same thing which we have drawn here. X direction, it is going only in X direction. So I can just change my view. It will come in a straight line like this. Then I'll use this beam, add beam option, and I'll go from node. This is very important. Okay. So if we do this, after this is done, I had shown you if you want to see the distances, you can see beam distance and dimensions. Display 5, 3, and 4. The same thing that we have got here 5, 3, and 4. Okay. Where did I go? I went for what? I went for my tools and I went for my dimension of beams. Okay. If you want to remove them, click on remove and click on remove from here. Those will disappear. All right. Okay. Same shift N. Okay. If you use shift N, you'll be able to the node points which are there here. 1, 2, 3, 4. You can see 1, 2, 3, 4. If you want to know which node is which, you can do this. Hit shift and it will go. All right. So the basic construction or the basic modeling of my beam is done. Now I have to add things to this beam because right now this beam is nothing but a single straight line. If I go for my 3D, if I just click on this pyramid here, you can see this is nothing but a single straight line like this. Okay. So for that, what I can do is I can just come and read here whatever they have given. See, they have given what kind of properties to assign. See, YD is 0.45 and ZD is 0.23. Okay, so like this, they have given proper steps for you to follow. All right. So I just randomly give things here. So we click on general, then we click on property. I'm going to go for define now. The very first step here is to click on define. You click on define rectangle, and we have to give the depth and the width value. So I'll just give 0.45 and 0.30. All right, and I'll click on add, close, select this. Now I can assign this by two ways. One, I can use the cursor to assign and click separately on each, or I can do assign to view because all these three have the same property. I can click on assign to view and click on assign. All right, automatically all these three will get the same property. Okay, so you can do this. Then we go for support. I'll click on create here, and after clicking on create, I have to click on print because there are no fixed supports here. So just click on assign, and I'm going to go and assign to these points like this. Okay, once that is done, supports are assigned, properties assigned. Next I have to come for loads and distribution. Now again, first I have to create empty load cases. So I have to click on add here, and I'll create a dead load case here. Okay, this is like the basic step. Every time you just make it a habit to repeat the steps. Then don't click on dead and click on add. You have to click on load case details again and click on add to create one more empty case called as live load. Okay, so once this dead and live load are created, inside these empty cases we can add whatever loads we want. So in data I want to add my self weight. Okay, because adding self weight is important. If you don't add it, it will give you an error. So use cursor to assign to you can do. I can click on assign. Okay, so that is done. Then I click on live load. Now comes the main point. If you we have to refer to this drawing again. So if you see my U real is how much? It is 20 kilonewton and it is only coming up till 3 meters. So how do I apply this load? To apply that load, basically I have to click on add. Okay. Now we were in self weight. Now I'm going to go for member load and I'll go for uniform force. My force is going to be minus 20. Okay, and you can see distance d1 d2 is given here. Okay, so d1 and d2 distance if I give, it will work. So d1 is 2, d2 is going to be 3. Okay, don't worry about d3, just d1 and d2, focus on these two distances. Okay, it's coming at what meters? 3 meters distance. So I'm just going to give d2 distance as 3. All right, then click on add, close. I'll select this, use cursor to assign, and I'll just assign it over here. So you can see it has come from here to here, just the way it has come here. So this is going to be my d1 and d3 distance, d1 and d2 distances. Okay, it's so easy to apply the load to a certain extent. Now when can this kind of condition come to you? See, this generally happens when you have what you call balcony. Okay, you have got your wall to a certain extent and then the balcony railings will come. Okay, so if you want to scale back on the amount of loads you're adding to your system to get a proper accurate results, that time what you can do is you can use this method. All right, so until where the wall is coming, you apply the wall load like this, and then for balcony you can let it be because 0.75 kilonewton per meter we add anyway on the balcony beam on top of it. Okay, so you can do this in that condition. This is where you use. Okay, so whether that's the first thing. Second thing is a point load, and this point load is adding in the middle of it, so we don't have to do much. Click on live load, click on add, and we have to go for member load. We cannot go for uniform force. You have to look at this picture again. See, it is the uniform force. I want what? Concentrated force, point load. So it will come, we get a point load like this. We add minus 10, and you can leave this to empty. Click on add and close. Select this, use cursor to assign, click on assign and click here. Okay, it will assign in the middle automatically. Alright, so whenever assigning in the middle comes to you, don't worry about adding anything like values here. you just let it be, it will take in the middle. Okay, if in case of util some condition like that comes, all you have to do is leave it, just leave it empty like this, like I have given values here, right? Leave it empty, automatically it assign that for the entire beam. Okay, next part is UVL. I have to add uniformly varying load. So you come here, go for a member load. And member load, you can see we have got linear varying load and we have got trapezoidal load. Okay, so you can apply the linear varying load at trapezoidal, but these loads, if you see, they are from what? From one end to other end of the beam. Okay, there is no distance value here. We can't give any distance here. If I were to give any value, it will take, like if I give 5 and 10 here, it will take 5 here and 10 there. So uniformly it will be varying from this entire space. Okay. So for this case, for this particular case where I have some space here and there, and initially I have no load, but at the end I have got 30 kN load. For that I have to go for trapezoidal load. Okay, so you have to be very careful. If the beam, if the UVL is being applied to the entire beam, and you have W1 and W2, go for the upper case. Okay, if you have just one single load, it is like this, you go for W3 like this. All right, but in our case we have got a trapezoidal load. Okay, so initially my trapezoidal load is going to be 0, and then my load is going to be how much have I mentioned here? 30. So I'll give minus 30. All right, and then I have to give D1 and D2 distances. So D1, how much my distance is? D1 is the distance from the point of the node. D1 is 1 meter and D2 is going to be 3 meters. On the whole, we have to give. Okay, so D1 is going to be how much? 1 meter. D2 is going to be 3 meters. Okay, D2 is taken from this edge, from this node point to that end. Okay, this entire distance we have to give. So if someone is confused, let me just do it over here once. For example, let me just let me just try it like this. Okay, say my UVL is coming something like this. Okay, this is my load. It is going in downward direction like this onto my beam. Okay, in this case what happens is, let me just change this to red. Okay, all right, so this is going to be my D1 value. All right, and this is going to be my D2 value. Let me just select this, add small d1, not capital, small d1. This is going to be d2. Okay, this is basically what has happened here. All right, so let's click on add. Okay, add and close. I'll select this, use cursor to assigning this, and I'll click assign here. All right, so after 1 meter distance, we have got our load like this. It is that simple. Now, one other very important thing. Let me go back to loads for a second. Okay, so one of the very important thing to note here is that I'm not able to see any values. So in the previous class when we were doing verification of results, I had shown you how to do this. All you have to do is come on top here. If you don't remember this symbol, it is just come on top here and just hover over them until you get symbols and labels. Okay, come on top, hover over here until you get symbols and labels, and then click on this. The first thing that you have to turn on is load values, because I want to check if I applied proper loads or not. All right, you do this, you come to scales and just 0.4, you just make it 10. Rest everything is visible in this picture. Just you make it 10 and apply an OK. So minus 20, minus 10, minus 30. Same thing that I have given here, minus 20, 10 and 30. Okay, you do this much, and then again you have to go for commands perform analysis, perform analysis, all. Okay, analyze, run analysis. You want to save it, you can save it. Okay, then you go for go to processing mode, click on done. It'll ask you the kind of loads you're considering. If you don't want to dead load, you can just send the dead load back. Okay, whatever loads you want, you can just consider that loads are the cases and you can just work with them. All right, so once this is done, like in the previous class we had discussed, MZ I have to turn on. Okay, I'll go for report, I'll go for results, view value, beam results, ending maximum midpoint, annotate. All the values will come to you. You just want to see maximum values, click on annotate, only those values will come to you. Okay, and the same thing you have to do for shear force also. Fy you have to turn on. Let me just turn off these values, uh, and we just turn on fz, sorry, shear force maximum, annotate, and you can see we're getting something that looks like this. Okay, if you want more values and results also, you can annotate and you'll be able to see all this. If it is not making sense, hold control and scroll up your mouse button. Okay, the diagram will expand like this for you. Same thing happens for MZ as well. Annotate this and click on expand, control and scroll your mouse button, and you'll get something that looks like this. It is that simple. All right. So this is how you're supposed to approach a problem when it is like this. Let me go for general once more. And before we wrap up this class, there's one more case that I wanted to discuss. There are a couple more cases, as in when you keep working on it, some of the other thing will keep coming to you. Okay. So we can just keep it simple support for this also. You don't need to worry about that. Just keep simple support here and keep a simple support here. And let's say there are 2 point loads acting here downwards like this. Okay. Now if my overall distance, let me just change the color to red. All right. Say my overall distance is about 6 meters. All right. And the distance between this and this, let's keep them equidistant. Okay. So my overall distance, let it be 6 or 8 meters, it doesn't matter. Okay. So let me just do it 6 meters. Let's not make a 8 meter beam. Okay. 6 meters we have got. So this is going to be 2, 2 and 2. Okay. So this I'll just keep mentioning it as 2 meters. Okay. So if you have a condition like this, how do you apply the load then? Okay. A simple condition. I've got two loads like this. Let's just say each load is minus 10. Okay. Minus 10 kilonewton. All right. The same thing for this, minus 10 kilonewton. Or if you want to change it, we can even make it minus 20. There is no issue about that. Okay. But if you have the same load, how do you apply it? We have to basically assign it 2 times. Okay, like this. So how do you construct this beam with that? So let me just come here. Let me just go back to my general option and geometry from there. What I'm going to do is I'll have 0, 0, 0 again, but this time I'll give it some value as the direction. All right, so let me just give some 4 there. Okay, so that way we have a, we just change the direction so we can see this. It's actually quite close. Let me just make it 10. Okay, that's much better. So next is next what I'm going to do. I'm going to give 6 meters and I'm going to give again the 10 meter distance again like this. It'll come. Let's go for it won't be visible. So we have to do this in this one zone only. Very quickly, I'll just add this beams here, node to node. Then I'm going to go for general property. We have to assign the property for it. Use cursor to assign. We have to assign the property first. Supports. I wanted to keep it simple support only. So I have to set the support first. Use cursor to assign, and then assign them like this. Then I'll come for loads and distribution. Loads, live load. Okay, and I'm going to add the live load here. I'll go for member load. I'll come and click on concentrated force and I'll give minus 10. Okay. Now the first thing is I want to give a D1 distance. So the first D1 distance is going to be 2. Okay. You can leave D2 to be 0. Add, close. Select this. Use cursor to assign this and click on this. So we have got 10 now. Now again, I cannot reassign the same load. I have to go back to live load. I have to click on add. I have to come back to my member load, concentrated force. Again, minus 10 I have to put. And now I have to increase my D1 distance as 4 meters. And click on add and close. Want to save it, just keep saving it. Just click on this. Use cursor to assign and assign it like this. Okay. So the distance that 2, 2 and 2 that you wanted, you have got like this. Okay. So you can assign loads like this as well. Again, then the same method follows. You have to go to your analysis, run the analysis and everything, and you will get your results from there. Okay, so I hope you have understood how to add loads like this after having space and they're not having complete going from one end to other end of the beam. Okay, so in the next class I'll most probably take up some more problems on beams, or I'll just go for portal frames, because in portal frames again we'll be applying the same loads only. Okay, now instead of having a beam we'll have a complete structure frame over there. Okay, so I hope you have understood this class. If you have a doubt, just let me know. We can add some more example problems if you have a doubt. Okay, so see you guys in next class. Thank you.